Hi guys, welcome back to my channel Pirai Academy. In this video, we are going to see about a Leetcode question number 322, coin change. So you are given an integer array coins representing coins of different denomination, okay, and an integer amount representing a total amount of money. Return the fewer number of coins, which means minimum number of coins that need to make up that amount. If that amount of money cannot be made up any combinations of the coin, then just return -1. Okay, so you may assume that you have an infinite number of each kind of coins. Okay, fine. So for example, if it is 1 comma 2 comma 5 and amount is 11, then I can be taking 5 two times and this 1 time, such that I'll be making the amount as 11. So how many coins I have to take? So I have to take 3 coins. Can you understand this? So they are asking us to find only the number of coins, the minimum number of coins, not the denominations. Okay, fine. So see here we can also take this 1 11 times, or we can take this 2 5 times and this 1 time, but they are exceeding our minimum capacity, right? So among all those combinations, the 3 is going to be very small. That's the reason why I'm returning 3. Okay, so similarly, coin is equal to 2 and amount is equal to 3, which means we cannot form this amount using the only 2 as the only coin, right? So I'll be returning -1. Similarly, coins is equal to 1, then amount is equal to 0, then I'll be returning 0. I'll be returning 0 because the amount itself 0. So why should I take any of the coins? 0 coins is required, right? Okay, so let us get into the problem. So the simplest and the first approach that comes into our mind is a greedy approach, right? So because they are asked us to find the minimum, so always we will be going to the greedy approach, right? So in the greedy approach, what we are going to do, I will sorting it in a descending order, which means 5 2 and 1, like this. Okay, now I will taking this 5 first. Okay, now amount is 11 initially, so 5 is lesser than this 11, right? So do a -5, which is equal to 6, right? Okay, now 6 is again lesser than the 5, then again do -5, which is equal to 1. Now whether 1 is greater than this 5 or equal to 5, no, at this point I'll be moving to the next thing. Whether 2, no, 2 is also greater than this 1, right? Now 1 is equal to this 1, so I can do -1, which is equal to 0. Now my amount became 0. So how many coins I require? 1 5 coin, second 5 coin, and then only 1 coin, which means the output will be going to be 3. Hope you understand up to this, right? So this is going to be a greedy algorithm, but this greedy algorithm is going to fail. Okay, so I'll be taking you another example so that you can understand what is meant by uniformity concept. Okay, so listen this carefully. We have some other combinations like 2 comma 5, and I am asking you the amount is equal to 8. What is the first step you are going to do? The first step I am going to do is sort in a descending order, which means 5 comma 2. Now amount is 8 initially. Whether 5 is greater than 8, sorry, 5 is lesser than or equal to 8, yes, then do a -5, which is equal to 3. Okay, whether 3 is greater than or equal to this 5, no, at this point I'll be moving this to here. Whether 2 is is lesser than or equal to this 3, yes, then do -2, which is equal to 1. Okay, 1 is lesser than this 2, right? So I'll be moving here, that's it. So from here I will be returning -1 as my output. Here I will be returning -1 as my output. But listen this, if I take 2 2 2 and 2, these 4 things, then I'll be forming the amount 8, right? But here what I'm returning, there is no possibility to form this 8. Now hope you understand why our greedy algorithm fails. So this is going to be the uniformity concept. Okay, like see here, this 2 and 5. With this 2 and 5, what are all the possible numbers we can form? So see here, we can form 2, and we can either form 3, no. We can either form 4, yes, we can form 4. But whether we can form 5, yes. Whether we form 6, yes, you can form 6, but without using this greedy algorithm. If I have 1 here, 1 comma 2 comma 5, then I can surely tell you we can form all possible numbers, because see here, by taking this 1, I'll be forming 1. By taking 1 and 2, I will be forming 3. By taking this 2 alone, I will be forming 2. By taking this 2 times, I will find 4. Can you understand this? So I can form all possible numbers by using this kind of things. Okay, so here the uniformity concept is followed. Okay, I'm just telling you, like, just understand this concept. It is going to be very much tricky. Okay, so when in question they have given like there are only 3 coins, 1, 2 and 5, or some other coins which is following a uniformity concept, then you can go with the greedy algorithm. If it is not, if it is a random coins, then surely you are going to be a combination type, which is going to be a recursion. We are going to form all possible combinations. From that, I want to take which is going to be efficient for me. Okay, which is going to be minimum. So here I can tell you, I'm going to take the recursion. I'm going to take a recursion. Okay. So initially, how my recursion function looks like, and I want you to just understand what is my recursion tree and recursion stack and how the recursion works. So the recursion works in DFS traversal, right? So I want you to understand these 3 things. These 3 things completely, then only you can understand this current problem. Okay, if you don't know about these 3 things, then you cannot understand this problem. That's the reason why I'll be giving the link for the recursion introduction in the description. Just go and watch it. Then come back and resume this video, because I only going to draw half of the recursion tree. Okay, if you want, you can fulfill that recursion tree entirely. Okay, so here I am going to draw the only half of the recursion tree. Fine. Okay. Now instead of taking this array, let me take only 5 and 2, so that the one of the case as amount is equal to 8. So this case is failed, right, in the greedy. Now we are going to make this case to be passed in this recursion approach. Okay, so how my recursion approach looks like? If it is 5, 2, the array, here you don't want to sort it, okay. So initially I be having a function which has where I am currently lying at. So whether I am lying at this 0th index or I am lying at this first index, like that. Can you understand this? So this is going to be one part. Okay, and then the next part is going to be what is the amount I have. Okay, amount I have. Okay. Now what I am going to do? How I am going to split this recursion into 2 kinds in one of the subproblem. If I am pointing towards this 0th index, I can either take this index 0 or I don't want to take it. Okay, so I have 2 choices. One is not take, another one is take. If I don't take it, what is the condition? There is nothing going to be the condition. I just move to the next index and make the amount as it is. If I am taking it, then what should be the condition? The condition should be the amount we have, right, should be strictly greater than or equal to the current index value. So current value. Can you understand this? Then only I can go to the same index. Again, go to the same index and then just go to the amount and subtract that amount from the current value. Okay, so if you till now you cannot understand this, I'll be drawing the recursion tree, then you can able to understand this. Okay, now initially where should I start? Initially I will be starting from 0th index, and what is my amount currently? It is 8. Okay, now I have 2 choices. One is not take, another one is take. Okay, for not take we don't have any conditions, just take it. Sorry, not just don't take it. So 1, 8. If I take it, I want to check for the condition whether this 8 is greater than or equal to this 5, the 0th index element. Yes. Then what should I do? I just take it. So if I take it, it will be something like 0, because I took this 5. I have 2 choices next. Like whether I took it, then I cannot take it again, or I can take it again, like that. Okay, so I'll be remaining at that same index, but my amount will be reduced by 5. So which is equal to 8 minus 5, which is equal to 3. Can you understand this? Yes. Now from here again, I can not take or I can take. If I not take, then it will be something like f of 2, 8. Okay, if I take it, I want to check whether this 8 is strictly greater than or equal to 2. 2, because 2 is the first index value, right? So whether it is strictly greater than or equal to 2, yes, then what do we do? F of 1 comma 8 minus 2, 8 minus 2 which is equal to 6, 8 minus 2 is equal to 6. Okay, similarly here also I can have not take and take option. If I don't take, don't worry, just go to 1 comma 3. If I take it, then I want to check whether this 3 is greater than or equal to the 0th index value. No. At this point, what should I do? I'll be returning some value which should be not affecting our recursion. Okay, so this value we can see at last, so that you can understand this clearly. Okay, now if I tell it, it will be won't understood. Okay, so from here I cannot go further. Just assume like that. Okay, now see here, what is this? F of 2 comma 8. 2 comma 8 means I am at the second index. Whether I have any second index value? No. At this point also I am going to return some value which is not affecting my recursion. Okay, fine. Now 1 comma 6. So from here I can tell you I have two possibility, because first index exists, right? So two possibility. So one is I can either go to 2 comma 6, or I can either go to 1 comma 6 minus 2 which is equal to 4. Okay, similarly here 1 comma 3, I can either go to not, or I can either go to take. If I go to not, it will be f of 2 comma 3. If I take it, 3 is greater than or equal to 2, right? 2 is going to be the first index element, so that's the reason why. So if I take it, it will be something like f of 1 comma 3 minus 2 which is equal to 1. Okay, fine. Now again come here. So this will be returning some value. Okay, I'll be at last telling you what it will be returning. Okay, now from here I can either go to not take or take. If I go to not take, it will be f of 2 comma 4. If I go to take, it will be f of 1 comma 4 minus 2 which is equal to 2. So here it will be returning some value which I'll be telling you in later. Now it is 1 comma 1. 1 comma 1 means I can either go to not take or take, but if I go to not take, it will be 2 comma 1. Whether I can take it, what is the value here? It is 1. What is the first index value? It is 2. Whether 1 is greater than or equal to 2? No. At this point I will be returning some value. Here also I will be returning some value, because the index is equal to 2. 2 is not a valid index, right? Okay, similarly now again here also it will be returning some value. Now here not take and take. Okay, now if it is a not take, then what should I do? Just go f of 2 comma 2. If it is a take, then I'll be going to 1 comma 2 minus 2, because 2 is equal to 2, right? So that's condition is true. So 2 minus 2 is equal to 0. Okay, now listen this carefully. It will be returning some value, but here what is my amount? Amount became 0. So at this particular point, what should I return? At this particular point I will be returning 0. Because whenever the amount is equal to 0, what we are returning in our question itself, here at this point amount is 0, so we are returning output as 0. Can you understand this? That's the reason why here also I am returning 0. Now understand this clearly. Here I have took. What I have took? So here I have took this 2, right? This first index value such a way that it became 0. So instead of taking this as 0, I'll be taking as 1 plus this recursion call. Can you understand this? Why I am putting this 1 plus? Whenever you are taking, put a 1 plus before it, then return the value of that particular function. So what is the value of this particular function? It is 0. So 1 plus 0 which is equal to 1. Can you understand why I am returning 1? Can you understand this? Because I have taken the index number 1 such a way it is also one of the part of my answer, right? That's the reason why I am putting 1 here. Similarly here, what should I return? Here I will be returning something like infinity such a way that we only want a minimum value. So if I return the infinity, then obviously other value going to be the minimum. So whether infinity or 1 is minimum, 1 is going to be minimum. So instead of this entire function, I will be returning as 1. Okay, here also I have taken. So here I have taken this 2. That's the reason why the 4 changed into 2. So here also what should I do? 1 plus. So 1 plus 1 will be 2. So 2, here it will be infinity. Can you understand why I am putting infinity and 2? Yes. So again, instead of this entire function, I'll be replacing as 2 because 2 is minimum among the infinity, right? Now here also I have taken so that the 6 will be reduced into 4, right? So here I have taken, so here put 1 plus. So 1 plus 2 which is equal to 3. So here infinity. So whether 3 or infinity, which is minimum? 3 is minimum. So instead of this every function, so I am replacing as 3. Okay, 3. Now here also I have taken. That's the reason why this 8 became 6. So here also put 1 plus. So 1 plus 3 which is equal to 4. Written 4. Now here comes infinity. So infinity of 4. So here I have not take. So whenever it is not take, I don't want to do 1 plus. Whenever I am taking it only, we want to do 1 plus. So here it will be 4 and here it will be returning 4 only. Okay. Similarly here, from here. So here it will be returning infinity and here also it will be returning infinity. Okay, because here is a cross condition. Whenever it is a cross condition, we want to return infinity. Okay, infinity. Which among them? Infinity. So I will be taking this entire function as infinity. Here I have taken it, right? So it is our responsibility to put 1 plus. So 1 plus infinity, again it will be infinity. Okay, so here also it is infinity. So these two are infinity. So obviously this is going to be infinity and it is a not take region. Whenever it is a not take region, we don't want to worry about it. Just return it. Okay. Here it is invalid. So here also it will be returning what? Infinity. So infinity. Which among them I will be taking? Infinity. Okay. So here it is true condition. Whenever it is a true condition, do 1 plus. So 1 plus infinity, again infinity. Now 4 and infinity. 4 going to be my output. Can you understand this? So this is your entire recursion tree for the given array, for the given input. Okay. If you are trying for this, it will be a huge recursion tree. Okay, that's the reason why I have taken this failed condition for the greedy approach. Okay. Now what I want you to understand is, like at this particular point, it is 1,8, right? 1,8. Let me draw again the recursion tree. Please pay patience because I want you to understand all the lines in the program. That's the reason I am teaching you everything. Okay. Now initially I have started from 0,8, right? And what is my array? It is 5,2. Okay. Now where I am going at first? At first I will be going for not take and next I will be going for take. Now not take means it will be 1,8. Similarly, if I am going for take, it will be f of 1 plus f of, so 5 is taken, right? So again I will be taking this 5 only. So 0,8 minus 5 which is equal to 3. So this is what we have taken as of now, right? Now just understand this clearly. Here it is what? F of 1,8. 1 means I have reached the end. So if I reach the end, then I want to do again and again that process, right? Again and again that process for the same number. So instead of doing that again and again, I want to check whether 8 is divisible by 2 or not. Yes, it is divisible. Then I will be just returning 8 divided by 2, which is equal to 4. Just return 4. Instead of going to all recursion calls again and again, like see here, from this, everything are what? Everything are same recursion calls. I will be taking and not taking. And these everything will be returning infinity. Instead of this, here itself I will be checking whether my 8 is divisible by 2 or not. If it is divisible, then I will be returning 8 divided by 2. If it is not, I will be returning infinity. That's it. I understand this. Similarly, here also, at some particular point, right? Here, what it signifies? First index means the last index, the 5,2. So I am standing at this 2. Okay, what is my amount? It is 3. Whether 3 mod 2, which is equal to 0. No. At this particular point, what I will be returning directly? I will be returning directly the infinity here itself instead of going to these recursion calls, these all recursion calls. Can you understand this? So this was the final recursion code. Okay, I want you to understand why I am putting this in the base condition. I will be showing that clearly in the code. Okay, now tell me what is the time complexity. So time complexity will be overall of 2 power n, overall of 2 power n. Okay, then what is the space complexity? Will be O of n. Sorry, time complexity will be overall of 2 power n. N is going to be the number of array elements cross what is the amount. Okay, and space complexity will be over n cross amount. That's it. Because of the recursion stack, this space complexity, and time complexity is because of we have for one recursion call we have maximum of 2 recursion calls, right? So for n cross amount recursion call we will be having 2 power n cross amount recursion call. Okay, fine. So let us see the code. So see here, this is going to be the Java code. If you want Python or C++ code, just go and search in the description. Okay, fine. So first of all, I'm taking n in the n as the length of the coin. Okay, now so let me delete this. This is unwanted. Okay, now at first I'm storing the helper function value into the result. First let us see the helper function, then we can come back to the result. Okay, now see here is going to be the helper function. There are 2 varying variables. One is index, another one is amount. Okay, now I'm checking whether my index is standing at the last index. If it is so, then what should I do? I'll be just checking whether the last index element will be dividing the amount successfully. If it is dividing the amount successfully, then just return amount divided by the last index value. That's it. Or else just return infinity. Okay, similarly here, first of all, pick. If I can pick, then I want to check for some condition, right? What is the condition? If the current amount is strictly greater than or equal to the current coin. If it is so, then what should I do? Pick is equal to 1 plus. I have picked that. That's the reason why I am putting 1 plus recursion call of stand on that index itself, but reduce your amount by the current coin. Okay. Similarly, for the not pick, what I should do? Go to the next index and don't change the amount. That's it. Okay. At last, return the minimum amount. Okay. Now come back. So here the result will be having the result value, right? Now, if that value is equal to the infinity, then there I can confirm I cannot get that possible value. So I will be returning -1. Okay. I cannot form that amount by using these combinations of these coins. That's the reason why I am returning -1. Else I will be returning resultant. If you submit it, won't be submitted successfully, because I am pretty much sure here the amount and the coins will be taking the huge time complexity. That's the reason why it will be not submitted successfully. So we want to go to the another approach, like we want to go for a optimization. So the next optimization is memoization. Okay, so what is meant by memoization? So in our recursion tree, it is a small recursion tree I have taken. In some other recursion tree, when you are going for a huge problem, then just try to understand this. Here I have occurred like 2,8, right? 2,8 or something like that. Here also again I will be occurring 2,8 sometime in some other recursion tree. Then or else make it simple. Like here it is 1,8, right? Here it is 1,8. Again here also it will be occurring 1,8 in anywhere else. Okay, but this 1,8 will be finished first, right? So because of the DFS nature. So if I just store this value in my memory, okay, when it is again occurring in that, just I don't want to compute all the values again. I'll be just taking out or just accessing the value that is stored in the memory, and I will be returning that result instead of going to all the recursion calls. Can you understand this? So this is what we are going to do in a memoization, so that our time complexity will be hugely reduced. So see here, what is the second step? It is going to be memoization, and this memoization can be done using hash map or using array. I prefer you to use array, and also you want to do in a hash map, because the hash map will be the quick approach, bit slightly inefficient, while array is something like you may do any mistake in array, and also it is quite harder than the like hash map approach. Fine. So I will be teaching you the array approach, and you want to try the hash map approach after studying about the array approach. Okay, fine. So see here, the first step you want to note is what is going to be the dimension of the array, 1D or 2D, like that. So what is the varying parameter here? I and amount. So 2D array. So 2D array. Now the second thing is what is going to be your I value range and also the amount range. So I value will be starting from 0, and will be going up to where? Will be going up to coins dot length minus 1. Coins dot length minus 1. So which is equal to, I can tell you my I is going to be from 0 up to the last index before index value. To the last index before index value, which means my I value will be from 0 up to where? Up to n minus 2. Right? If it reaches the n minus 1, then automatically it is entering into this base condition, right? This base condition. So I want to go up to n minus 2. Similarly for amount also, it will be from where to where? It will be starting from amount, okay, and it will be ending up to where? Up to 0. Right? So from this, I can tell you my array will be going to be like I number of rows and amount number of columns. Okay, which means starting from 0 and ending at the amount as the one of the index. Meanwhile, my I is going to be starting from 0 and ending at what? At n minus 2. Can you understand this? Okay. Now, what should be the values should be filled among them? So that's going to be next step. Okay. So what is the value that is not returned here? So infinity is returning, 1 is returning, and 2 is returning. Anything may be written, right? So we won't get anything like minus 1. We won't get anything like minus 1. We won't get anything like null. Okay. So your choice to fill everything as null or everything as minus 1 or minus 2, minus 3, anything that should not be returned from any of the recursion call. Okay. So let me keep everything as null for simplicity. Okay. All will be null. Okay. Fine. And then what is the next line I want to add is after this base condition, I want to add one more line. If take for example, this is a DP. Okay. If DP of I and then amount, okay, which is equal to, which is not equal to null, then surely I will be returning that value. Okay. Now similarly, before returning, okay, I want you to update it. So I and amount will be equal to minimum among pick and not pick. Okay, then return it. Okay. So instead of this one line, I'll be adding these. So now your entire function is converted into a memoization. Now tell me what's the time complexity. So time complexity is hugely reduced into n cross amount, and space complexity will be hugely reduced to remains same because of what? Because of two things. One is we have taken a matrix and we are taking an auxiliary matrix and also a recursion stack. So because of these two things, my space complexity will be O of n cross amount. Okay. So this is what the entire thing you want to change from the recursion code into a memoization code. Fine. So let me take out the coding part. For that, just a minute. Okay. Let me comment this out. So see here, this is going to be a memoization part. So as I told, it will be n minus 1. So that's it. Okay. So see here, first of all, my DP is going to be what? N minus 1 cross amount plus 1. So this is going to be a dimension. I already told you, right? So index will be starting from 0. The row number will be starting from 0, going up to where? Going up to n minus 2, the index value range. Meanwhile, in amount, it will be starting from 0, going up to amount as the index. So it will be amount plus 1. Can you understand this? So what is the next step we want to do here? We want to add one more base condition. Okay, I have added. Now at last I want to return it after updating it. Okay, So let me run this. Yes, it is running fine, right? If I submit it, yes, it is submitted successfully, right? Because our time is hugely reduced from exponential into a polynomial or quadratic, right? So let me take this. We can further optimize it. So the next step of optimization is tabulation. So if you already saw my DP series, then you can know it. If you are new, then I'll be telling you why we are doing a tabulation. See here, this recursion stack is one of the factors that is affecting my space complexity, right? So if I just remove it, then that's going to be my additional advantage for space optimization. So the third step is going to be tabulation. Okay, so here also we want to do some set of rules. So hats off now, what is going to be our matrix dimension? It is going to be n minus 1 cross amount plus 1, right? So this is going to be a matrix dimension. Now I want to just slightly update this using the base condition. So see here, what is the base condition? So base condition here is if my coin of length minus 1 is equal to my index, then what should I do? I am doing some set of operations, right? So here by saying this, what my I should be equal to coin dot length minus 1, which means n minus 1. But hats off now, this is our matrix. Okay, just think like, so our matrix will be rows are starting from 0 1 2 up to where? Up to n minus 2, whether we have n minus 1, because our base condition is telling what coin should be coin's length minus 1 should be equal to index, which means we also want n minus 1, so add one more row. Can you understand this? How I am going to add one more row? Yes. Now, how many columns we have? We have columns from 0, 1, 2 up to amount plus 1. Sorry, amount. Okay. So here you don't want to change anything. Can you understand this? Here you don't want to change anything because see here, our amount will be ranging from amount up to 0 only, either in the recursion or in the memoization also, the base condition also. So that's the reason why I am taking the amount as it is. So what is the alter the thing here? So the dimension changed into n cross amount plus 1. Can you understand this? So this is our new dimension. And what should I update in it? So see here, I want to go across all the across all the last index, like means the last row at this particular row, the n minus 1th row, and I want to just take the amount mod the coin's last index value, which is equal to 0 or not. If it is so, then I want to just initialize them here. Can you understand this? Okay. Else I want to initialize the infinity value. In code I will be showing you this clearly. Okay. Now what is the next condition we want to do? Just always skip this base condition. Okay. Okay. Now rest of them is body of our recursion. So whenever it is a body of the recursion, put a looping. We are just removing the recursion. Then we want to go for obviously for looping. So put a for loop for, first of all, I will be from where to where? Will be starting from 0 and going up to where? Up to n minus 1. Which means it will be going up to n minus 2 only. It will be ending at n minus 2. When it reaches n minus 1, it will be the base condition. So here in tabulation, do a reverse fashion, which means starting from n minus 2, going up to 0. Okay. Similarly, for our j, where it is starting at our amount and going up to the amount is equal to 0. So here the amount will be starting from 0 and going up to amount. Okay, fine. Now let us take this as a DP again. Now write all other lines here also. So pick is equal to infinity. Okay. Now if my coin, so this statement is here. Now what should I do? Pick is equal to 1 plus. So helper is going to be the recursion function. Whenever there's a recursion function, put a DP of I is going to be one of the varying parameter, and another varying parameter is what? Amount minus coins of I. That's it. Can you understand this? Okay. Similarly, after this if put not pick is equal to, again helper, whenever this helper, put a dp of I plus 1 is going to be one of the varying parameter and another one is amount. Okay, then here I am updating it, right? So whenever there's an updation, put dp of I and amount is equal to pick, minimum of pick and not pick. Okay, at last after finishing this entire loop, what should I return? I'll be just returning what is the value I have written here. So here I am returning these lines, right? These 3 lines, right? So if my helper function of 0 comma amount, that means dp of 0 and amount. Can you understand this? If it is equal to infinity, then return -1. Else I want to return this value. That's it. Can you understand this? By doing this, now I can tell you that time complexity is over n cross amount, but my space complexity is also n cross amount. The only reason behind it is we are only having a space complexity as a matrix, not the entire recursion stack. That space is removed. Can you understand this? Okay. So let me get into the code. Now you can understand the code clearly. So see here, this is going to be your tabulation code. So see here, first of all, I am taking the dimension as n cross amount plus 1. Can you understand why I modified it? Okay, fine. And then I want to update. I want to go from t is equal to 0 up to t is less than or equal to amount. Okay, I'm going to all possible columns, and at the last row, I will be checking whether my t, that amount mod coin -1 is equal to 0 or not. Can you understand this? This is what I told there also. If it is so, then in my last row at that particular column, I will be updating as the division value. Else I will be updating this as infinity value. Can you understand this? So this is what the base condition transformed into the tabulation method. Okay. Now here I will be traversing from n-2 up to 0. Here I will be starting from 0 up to amount. Just do a reverse pattern according to the recursion function. Okay. Now not pick going to be like this, and pick will be going to be like this, as I told you already. Okay. And then at last I am going to update them. Now at last I want to check whether the dp of 0 and amount is equal to the infinity. If it is so, I will be returning the infinity. Sorry, I will be returning the -1. Else I will be returning the answer. Can you understand up to this? Right. So this is what your entire tabulation code. Now in this tabulation code, we are further going to another optimization called space optimization. So let me save this, get a new thing. Fine. So now this is going to be your space optimization. So see here, let me take this. Fine. So I already told you why we got the space, right? So that now the space is only because of the matrix. Now we want to reduce the matrix dimension, or we are going to check whether we can entirely remove the matrix. Okay. So it is going to be the fourth approach. Fine. The optimization. Now what are the things I am going to check at first is, go to the inner loop. This focus on these lines. Okay. Now here I want dp of I plus 1. Okay. Here I want dp of I. Okay. Here also I want only dp of I. So which means these 3 lines are defining like, hey, you want only one row and its next row, which means I want only current row and then next row, such that this current row will be of amount plus 1 column. Similarly, the next also starting from 0, 1, 2, 3 up to amount, which means amount plus 1 columns. Can you understand this? So I want only two rows, such that this will be dp of I and this will be dp of I plus 1. Can you understand up to this? Right? Okay. Now what are the things I want to do? Instead of taking the DP as like this, I want to take as two arrays, two individual arrays. Now you want to write these all lines using the next. So instead of DP of n minus 1, we want to update this as next. Here also next. Can you understand up to this? Here also you want to that's it. So these two lines are converted into a next. So we have updated the next array. So this array. Okay. Now instead of declaring this current here, you want to declare the current here, because you want to again and again initialize the current. We don't want to carry the value of the current here. Okay, so we want to reassign the current to null again and again. We want to just take out the values. That's the reason I am just adding the current initialization here. Okay, remaining everything is same. Now in this line, in this particular line, in not pick, I will be just taking, instead of DP of I plus 1, I will be taking what? Next of t. Similarly at this particular line, in pick, I will be taking like 1 plus current of t minus coins of I. Why I am taking like this? Because here it is DP of I. Instead we want to take current. Okay. Now in this line, I want to take as current is equal to minimum among pick and not pick. Okay. Similarly at last here, what should be my value? So here my value should be next of amount. Okay, and also I forgot to mention one line. So at this particular point, after finishing this loop, after finishing the inner loop, we want to update one more line, like we want to update the result in the next. Okay, so next is equal to current. That's it. So this is going to be important line, because see here, I have a matrix, for example 0 1 2 3. Okay, at first I'll be taking only these two rows. Okay, only these two rows, and updating all the result in this second in this. Now in the next iteration, the second it is going to be my answer. Okay, meanwhile by using this answer, I am going to update this first in this. Then by using this first in this as an answer, I am going to update this 0th in this. At last I will be returning anything in this 0th in this. So this is what we have done in the space optimization also. If you want to understand this, just go and try run all the approaches. Okay. Now tell me, what's the time complexity? It will be O of n cross amount. Meanwhile, what is the space complexity? It will be O of amount. So this is going to be your entire space and time complexity. Now, see here, let me comment this and show you the space optimized version. See here, this is going to be a space optimized version. So what are the things I want to change? First of all, I am just declare the next. Okay. Now here, instead of using the DP of n minus 1, I used the next here and next here. Similarly, here I have declared the current. Okay. Now here, instead of DP of I plus 1, I used the next. Instead of DP of I, used current. Instead of DP of I, used current. And at last, I am just initializing the current into the next, which means I am updating the result for the next iteration. Okay. And then here, instead of DP of 0, I just updated as next. Okay, fine. So this is going to be your entire space optimized code. If I submit it, it will be submitted successfully. Yes, it is submitted successfully. So to know about these kinds of algorithms, just go and search in my YouTube channel. And if you really like this video and understood the concept, just like this video and subscribe to my channel. And don't skip any videos in this DP series, because all the DP series videos will be helpful for you to understand the DP concept clearly and to crack the DP questions. Okay. If you have any doubts in these approaches, just comment below. I'll be commenting the answers. Thank you.